Hello everyone, good evening or good afternoon, welcome. So nice to see so many of you staying after a long day for what will be a talk about, well, databases and data. Not a very new subject, but hopefully I will give you a new perspective on it. To those of you who have not met me before, my name is Rafał Lukawiecki. I don't work for Microsoft. I have never worked for Microsoft, but I have worked with Microsoft for 26 years now. And in the last 10 of those 26 years, I have focused on analytics, on data mining, on predictive analytics. Now it's called data science, but it's pretty much the same thing that I've been doing for about 10 years. And I am very pleased that for you over here, I have been asked to prepare a new presentation, one which I have never yet presented before, which summarizes my observations about the changes to the world of databases. So hopefully you will find some of it useful, and hopefully you will share some of these observations with your experience. Before I proceed, just a couple of quick words about getting in touch with me, rafal@projectbotticelli.com, as well as my Twitter hashtag @rafal.net are at your disposal. Right. What I really would like to do in this 1 hour and 5 minutes or so that I have is to give you a holistic view onto database evolution. And in particular, I want to present it as data versus the needs of developers, the needs of analysts, the needs of users, as well as the needs of business and perhaps very importantly, of database administrators. Out of interest, how many of you in the audience are DBAs? Could you just raise your hand? I'm kind of curious how many DBAs we've got. Oh, okay, we've got about 10, maybe 5% of you. Okay, we'll go easy on the DBAs then. They're in minority today. They're normally very vocal. The reason I said analysts in italics is because this is what I do. So a lot of the perspective you will see will be slightly skewed towards that analytical perspective, I suppose. Very briefly, my company, Project Botticelli, amongst other things, offers online and classroom-based training on the things we do. We are a very, very small company. We only offer very few courses, but they are by some of the best-known people in business. As long as it is connected to the world of analytics or business intelligence, we've got it. I teach data science and data mining. Alberto Ferrari and Marco Russo teach data analysis, expressions, and power pivot. Chris Webb teaches about multidimensional analysis and SSAS cubes. And Bob, you'll hear about Bob a little later, Bob and his wife Carmel teach about enabling companies to better use Excel to make sense of their own data. And we have a special offer for everybody attending here with the code 50 TechDays 2016. You can get $50 off our annual memberships, which expire, this code, at the end of the month, at the end of the coming month. It's a leap year, remember, so you have still a month. Okay, what's data? Well, let's open the Oxford English Dictionary, and we learn that the word data has been defined in the 19th century, early 19th century to be precise, as a piece of information. All right, well, that clarified a lot. But then, interestingly, we move to the world of databases. And this is where Oxford English Dictionary is a little bit funny, because it doesn't try to define it as a database. It tries to evade it by describing it. It's like a secondary definition. And what they kind of focus on is that what makes data into a database is organization. Organization that puts data into a store so that computers can process it, but how? What's the purpose? What's the reason for this organization, you may ask? Well, Oxford English Dictionary doesn't explain that, but the practice, and indeed if you look into some American dictionaries, you learn very quickly that the purpose of this organization is to make the organized store of data work well enough for users to use. Basically, make the data somehow usable for the users without hopefully too many bugs and too much downtime, and hopefully people don't complain about it too much. Well, that's what a database is. It's basically a system that just somehow manages to deliver data to others. But as soon as you focus on this, perhaps, aspect of organization, there's one unpleasant word in there that we love to argue and discuss and debate and disagree. The word is model. When you want to model something, I can guarantee to you that no two people will want to model it the same way. And in fact, almost everything we do in IT is some modeling of reality into an abstraction. And in databases, this is one of the areas where we have been evolving the most in our world of information technology. In the 60s, we started with navigational models because computers were slow and we had some limitations. You know, I may look very young, but I have been in IT for quite some time, and at my expense, I brought one of my most treasured possessions. Do you know what this is? I don't know if you do, but if you look at this, it says Luke tape. Look, my surname, Lukawiecki, that was my tape. ICL 1905, 2nd of June 1985 is when I wrote my software on it, and I'm not going to show you the software, but I will explain to you one important thing. It's a sequence. If you want to read data that's behind you, that you've already read, it's not going to work unless you rewind the tape. So, in order to organize data on a mechanism like this, we have to model it in a way that only works for sequential reads. So what happens if you want to pivot the data, for example, from a row into a columnar order? Well, that's exactly what I wrote. The program which is over here is your early version of a pivot table. This is a pivot table, and it pivots data by reading it in a clever way and keeping it in memory. I had to do it this way because that's all we could do at that time. And by the way, sometimes these things were really very good. Do you know what this does? It's a bit sticky. Do you know what have I done? I write protected it. Nobody can write to that anymore. Yeah, that's great. That's great stuff because people used to overwrite my software all the time. But there you go. Now we have to do locking and all of that. All right, I'm digressing. We quickly improved the way we store data. So we moved away from navigational through hierarchical models into the era that made today's computing possible, of course, relational database management systems. Relational database management systems at first did not have a great idea behind it. That was kind of retrofitted a little later because of workings of this very, very innovative guy, Mr. Code. And very soon, 6 years after relational databases became popular, the entity relationship modeling approach became prominent, and that's what probably many of you had to learn at some point in your career. Then we started making it more detailed for purposes of analytical rather than transactional processing. Star schema modeling became a very important and still widely used way of logically modeling data. And in the 90s, we tried to implement object-oriented databases, but they weren't really working very well. In fact, that was when I was doing my later projects on deductive databases. One of my early projects was a system for managing safety of nuclear material, and I had to figure out how to do it in a safe way. I tried object orientation for that. It was a nice idea. In practice, it didn't work. And then suddenly, something changes. Suddenly, computers become much more powerful, and suddenly people are no longer constrained not just by the magnetic tape, but by the limitations of processing, and they start writing much more inefficient code for dealing with data, but much more interesting, which enables us, for example, to store data as documents rather than as rows and columns and tables, as graphs, as entities that are so different from this old idea of columns and rows, not to mention from the sequences. In sequences, every record had a pointer telling you what's the next record. So if you wanted to stick a record in the middle, you had to rewrite the records on the left and the right. Obviously, we have departed from that era. However, not entirely departed fully, because some of those old concepts of hierarchical databases reappear now again in document databases. Some of those old entity relationship ideas reappear as entity attribute value and more modern key value or key attribute storage mechanisms that are growing fast. You may want to ask a question, why? Surely with all of that amazing innovation behind relational databases, which importantly state, and that's been proven, that everything you ever want to store in a database can be stored in a relational database management system, we shouldn't have to do the rest. Is it just for academic purposes? No. There is a reason, and I'm going to explain to you what this reason is, but I want to put it into perspective of time. There are three eras in databases: the pre-relational, relational, and post-relational. The pre-relational, I already told you, the tapes, the hierarchies, networks. The relational, you all understand: SQL servers, oracles, DBases, databases, and so on. Post-relational is, of course, the world of young kids innovating in NoSQL, NewSQL. Have you heard of NewSQL? Not many of you. Have you heard of NoSQL? You must have. I have a slide on NoSQL, so don't worry, we'll come to that. In case you haven't heard about NewSQL, NewSQL is NoSQL with SQL. So it's, is it NoSQL after all? No, it's just NewSQL. Okay, we'll come to that later. All right. Obviously, this presentation is about the future of data and databases, so as you would expect, I am going to focus on the post-relational part for the rest of this presentation, and I will focus on its uses for both the things I do in a little bit more detail and in a little less detail for the things that I don't do, and I will summarize with a glimpse of where it's all headed behind the post-relational era. There are really four reasons we are doing this. This departure from the relational era is done almost always not for one, but for at least two reasons that you will pick from this chart. The most typical reason is that we want to do things today faster, in a more scalable way, in this dramatically distributed world that we live in. Web 2.0 began something that led to the world of software that gets its data from systems which are so heterogeneous that it can never be put probably at any point in time into one store, not to mention that all of those systems have their own levels of reliability, they fail, connectedness, availability. The distribution of computing, if anything, continues to explode. People talk about explosion of data. That would be a small problem. Much bigger problem is how distributed this growth of data is. Just think how many databases you and your company use today, and compare that to where you were just 5 years ago, not to mention 10 years ago. At the same time, we want things faster. Developers are told to code faster. In the world of DevOps and continuous integration, continuous development, we no longer have the luxury of designing everything beautifully. I'm not going to name any names, but there are companies behind very successful products we use in daily life, like cars, who are testing their software in production. I mean, they are developing software for critical things when people can die. That's something we couldn't even imagine doing about 5 to 10 years ago. So developers want the closest paradigm to their mindset when they code. They don't want to learn SQL. Nobody likes SQL except for DBAs. Of course, everybody has to learn SQL at some point, so this is the price we all pay eventually. But the truth is that there is a grain of reason to it. And the grain is that when the developer thinks about invoice systems, the developer thinks about an invoice very often as a document and not as a table of tables with relationships and whatnot. So there is a disconnect between the world that relational databases supported and what we want actually to use when we don't have time. If you had the time to design everything and test it properly, it would be a different world. There's also an interesting debate going. What is more important, database consistency or your application consistency? And you can guess that DBAs know very well that consistency of a database is paramount to what they do. But developers don't care. They care much more now about having consistent user experience and much less about the database. As long as not too many people complain, we consider the application to be successful. You know, that wasn't the case even 5 years ago. I'm not necessarily saying this is wrong. I have problems with it. but that's where the world is going, and we have to live with it, and we have to support it. Then there are people like me who want special features. I want databases which allow me to store a row that has 1 million columns. You may wonder why. I will explain that later. I will show you why. It's a very common request in machine learning. And as it happens, in SQL Server, as much as I use it extensively, it's not very easy to have 1 million columns. So we need sometimes to use something simply because we have a feature we like. And of course, some of them are free. It would be nice if SQL Server was free too. Let me focus on one aspect of this why. The CAP conjecture, also known as the Brewer's theorem. Some people call it the CAP theorem, but it's not really a theorem. Without spending the rest of this hour talking about what makes a theorem and what doesn't, there is this guy, Eric Brewer, who kind of presented a keynote a bit like mine, slightly better, and in it he said around year 2000 that you cannot have consistency, availability and partition tolerance at the same time in a distributed system. You can have any two you choose, but not three. In other words, if you want the data to be consistent everywhere, great, that's fine, choose one more. Do you want it to be available at all times? That's great, but then your system can never disconnect. It always has to be connected. Oh, I can't have that, my system disconnects. Fine, then give up. Availability, meaning you will wait for the results until it synchronizes, fixes, or equilibrizes, as it is called, or you give up consistency, meaning that the data will be right here or wrong here, and we will just not know which one is right and which one is wrong. And this is a big debate, because the world of traditional databases generally preferred consistency over availability. Who cares if the row is locked? Tell them to wait, okay? But the new guys say, no, my user is getting upset, I need to show the user something. What if it's wrong? Who cares? Just one user will be unhappy. All right, well, funny as it is, that's what's winning. What is currently winning is the world where we accept globally inconsistent data, provided it's locally consistent. In other words, as long as we can somehow ensure that for this user it's okay, we don't care if for everybody else things are wrong. And if you are struggling to understand how to make sense out of it, well, welcome to the world which is the reason for NoSQL. NoSQL originally was, we don't need SQL, then it was renamed Not Only SQL. In other words, yes, you can use SQL if you want, but you can also not use it. But really, this is the world of representing data with one huge shift. Shift in which we accept inconsistency as a fact of life. And actually, it's not such a huge shift. This has been done before. Traditional example of when we need consistency is financial transaction processing. Right? Most people would say yes. That's why we had properties of database systems such as ACID, atomicity, consistency, isolation, and durability. But you know what? Even with those fabulous databases that financial systems work, can someone explain to me why does it take 3 days to transfer money between 2 accounts in most countries in the world? There's a reason, and the reason is that computers go wrong. But in those 3 days, the user, the operator, the bank owner will spot the issue, even if computers fail to do so. So, you know, these guys behind all of these NoSQL databases are saying, well, even in the world of those amazing ACID, durability, isolation, all of that stuff, you still have to wait for eventual consistency, as it is called, which happens only when a human operator says it is right. So really, this debate is not a clear-cut answer today, especially when you include the user, the human element in the process, which is increasingly happening more often as we all use devices, as we all drive internet-connected cars, as Internet of Things is affecting a light bulb at your home. Did you realize that your light bulb probably has a Linux server on it now? I mean, I never believed that would happen. You know, I have reasons, you know, that was amazing for me, but it's happening. All right, I'm not going to discuss the difference between column, document, key value graph, and multimodal. I copied that from Wikipedia, so you can go to Wikipedia and read more about it. But I want to highlight one thing over here, just one. Document databases, the reason, and that's a good example, the reason they are becoming popular is because they allow us to solve some of those problems of consistency in a clever way. We don't care so much whether the elements of the invoice are right. We care that the whole invoice is right. So when we store the invoice as an entity, which is slightly more granular, of course, it's easier to maintain its consistency than maintain the consistency of individual columns and rows in 50 tables from which parts of that invoice have been built. And that's a lot of thinking behind why document databases are starting to appeal to people. Unfortunately, all of these things, so many of them are highly fragmented, highly incompatible, highly specialized, nowhere near as well supported as beautiful traditional relational database management systems, and absolutely not understood as well. We don't understand the implications of that world yet. We might one day, but right now we don't. All we know is that they solve some problems whilst creating some other problems, and maybe they have a future. Where is that future? That future is in two worlds, the world of operations and the world of analytics. In the world of operations of the now and the future, as you already know, we are building new line of business applications every few days, every few hours. The world of operations is still critical, but it's becoming even more critical when it fails. And time to market is shortening. We are demanding that developers do things which are almost impossible to do. I know many of you are here developers, so if you feel like you have too much to do, not enough time, and the requests are becoming unreasonable, I am with you, because that is true. And it will get worse, so just get ready for the future. In the future, you will be deploying most likely untested software, which will be tested by a computer, and it will be only considered buggy if, hopefully, not somebody dies, but at least the car doesn't crash. You can do A/B testing. Shall we change the way the wheel works from left to right? We'll see. Oh, too many crashes. Let's, unwind that. Yes. It's called predictive testing. All right. In the world of analytics, fortunately, we are much more tolerant. We have a longer time frame now. We have, unfortunately, the influence of end-user computing that we have never expected to have before, meaning, for example, Excel spread marks appearing everywhere. And unfortunately, for those who have to maintain it, and fortunately for those who use it like me, we have the most innovation happening here. The world of big data, and I don't like that name, by the way, because there's nothing big about the data than the name, but big data is the world of the most rapid analytical innovation, not yet so much for operations, and probably for the better. So let me talk about those two worlds separately. First of all, I'll talk a little about the world of operations, because this is not the world that I understand as well. I will focus on analytics just a little bit more. As you already know, speed of development is currently key. And that means that the developer will choose a database model that is closest to what the developer is currently trying to develop. Which is why, when you are told by your boss to develop this web service that does X, you will probably choose a NoSQL database that is designed for X rather than anything else. As long as you choose a database very, very well for the purpose, you've done some research, that's generally the fastest way to develop an application today. Then your boss will say, scale it. At that point, you will start hacking it, because most likely the system you have chosen has never been designed for beautiful automatic scalability, and even the good ones that have been designed for scalability have issues that require some hacking sooner or later. And then, if you were successful, a few months, maybe years later, you will be told that your beautiful system, which works very well, has to integrate with every other system you have in your company, at which point you will start migrating it away from your NoSQL and towards something that everybody else uses. And yes, this is a time where you will learn how to do SQL, and this is the time where you will hire a good DBA who will go and say, And, after they complain for a few months, you will end up having almost as good a system as you had in the first place. Sure, you will lose some functionality, users will be complaining, but it will interoperate with everything else. That doesn't sound good, does it? Couldn't we have like one and the other? Could we have like all of that goodness of SQL, but also all of that fabulousness of NoSQL? Well, that's kind of what new SQL is trying to do, but it's not ready yet. So maybe sometime in the future. In the meantime, you're going to have to suffer. In the world of analytics, you have three options. Classically, ETL. Classically, you extract, transform, load, and then you have your data warehouse, maybe a data mart, maybe a data lake, but whatever you've done, you have it in the format which is appropriate for analytics. This has been the case for years. Well, at least since the 90s when it became very popular. The more recent analytics, especially popularized by this concept of big data, usually do it slightly differently. You usually pick one of these three options. If you really want the sheer power and speed and scalability, you probably will hard code your data access into the analytics. Hard coding anything is never a good idea, but it gives you the speed, and MapReduce as a way of writing Hadoop code is very popular for that reason, but it's also the most non-portable code you could write. It completely fuses data with the application, with analytics. As a result, it's so expensive to do, so expensive to maintain, that unless you are really sure you want to do it, I would steer you away from that, because it's just too expensive. How expensive? I'll just give you an idea. If you are a developer who can do good MapReduce code, and you are in New York right now, the salary, although it decreased recently, the salary, your starting annual salary, will begin at $180,000 per year. It's getting cheaper. It was $250,000 a year. So I can't afford people like that, so I don't do that. I can't, unfortunately, code it in MapReduce. It's too expensive. The other way to do it, Hadoop-style ETL, is transform it, using the beauty of those new systems to transform the data into formats they understand. A classic example how to do it is Pig. Pig and Hive, they will live together. Those are two systems designed a little bit for that. And the third, most popular way to do it is to transform your strange data into something that looks like a relational database, but without maintaining its ACID properties. Basically, use a NoSQL type of storage for what is really a SQL type of a database. And this is so popular because it gives you the ability to move between SQL and NoSQL most easily. I do that a lot, and this is one of the reasons why I see that new SQL may have some chance in the future. So I already said a few times, this is what I do, so perhaps it's a good time for me to give you a little bit of insight into my world. As a practicing analyst, I live in that space. I am somewhere between wrangling or fighting with the data, some machine learning, doing some statistical analysis, and occasionally using some big data technologies. And those circles are not correctly sized. If I were to size them in proportion to where I spend most of my time, the biggest circle would be data wrangling, a smaller circle would be machine learning, and equal to that in size circle would be statistics, and the smallest circle would be the big data. Remember, big in the name, but not necessarily in anything else. It's useful. It's just a little overhyped. And anyway. So if you think about that, I need some people. My typical team is a domain expert, that's the client who understands the problem they want to solve, a data expert who understands the best database technologies available, and a data analyst. That could be me, that could be somebody else. Sometimes it's a data scientist, sometimes it's a multidimensional analyst, and we work as a group. Very often, the client works with Rafal and with Bob. And Bob is a real person, but I put him in italics because I speak so often of him that very often somebody else becomes, of course, the Bob. So why do I need Bob? Let me explain to you why do I need Bob. The reason I need Bob is because I have figured out that this is the most cost-effective, fastest way to do advanced analytics for my clients. Is that because Bob does analytics? No, he doesn't. It's because I, as an analyst, will never be as good as Bob in writing stored procedures and magnificent select statements that he can do. He is the best SQL guy I can lay my hands on. So when I go to a customer's engagement, I sit usually here, Bob is usually on my left, Bob will be transforming the data for me using SQL Server most of the time, Microsoft SQL Server, whether in the cloud or on-prem doesn't matter. I am analyzing it as fast as he throws the data at me, and I throw at him questions how to transform it as fast as he can service them. I have tried to be good at data, and I can be good at some types of data, but this is far better. This is much faster. And this is also where I see problems with many of my clients where I visit them and they are struggling with analytics. It's very often because they don't have Bob. They are very good at analytics and they think they should know everything about SQL. They think they should be really good at writing queries, and of course they are not. As a result, they try using other tools. Maybe they use some RapidMiner, maybe Alteryx is now popular, maybe some other product, and they design this absolutely corkscrew-like flows for transforming data, something that would take Bob maybe 5 to 15 minutes to do in the tool he likes, he understands, and which works very well. And if you think about it, I am not quite alone in doing it that way, and I will tell you in a moment who else does it that way. But just to give you an idea why Bob matters so much, I want to share with you this number. This number is what almost everybody in my business agrees on. No matter how fabulous an analyst you are, you will waste 80% of your customer's budget on data wrangling. I have never had a project where less than 60% of the budget was data wrangling, and I have had many projects where 100% was wrangling and we never managed to do any analytics. They paid. All right. It's actually not entirely true that it's just wrangling. I'm kind of lying a little bit. Wrangling is often half and half with this thing we call feature engineering. In case you've never heard about it, that's okay. Mostly machine learning people use this term. Feature engineering means adding more columns. You start with columns such as a person who has gender, age, and then you say, well, but what about the gender of their partner? What about the income of their mother? Did they buy 5 widgets? And did a person in their family not buy a brown widget if their mother bought it? You get the idea? That's what I do. That's what I get paid for. I sit in front of customers' data and I add more and more columns like that. We love adding columns so much, we have software that does it for us. Have you ever seen text analytics? Very easy to do. You take text and you convert it into columns. The easiest way to do text analytics, take some text and convert it into, how many words are there in German language? No? Nobody knows? No? All right. I guess a lot. Let's say a lot. Maybe as many as in the English language. Modern English, that is after the 17th century, there's approximately 300,000 words in continuous use. Most people living in London know 3,000, but about 300,000 are generally used. So how do I do my project? I just create a row that has 300,000 columns for every word, and I put a number. And this number is 2, because this word was twice in this document. That's it. Trust me, most text analytics is done like that. Okay, 300,000 columns is too many, so we hash it, and we sometimes don't have 300,000, sometimes we have like maybe 10,000, but it's still the same idea. We make columns. This is called feature engineering, and that requires Bob. that's not something I can do alone on my own, at least not successfully. So, in my world, guess what tool is the #1 tool for advanced analytics? And in fact, if you ask this question to everybody who is a data scientist, thanks to O'Reilly Media survey, it turns out that after we politely ignore the question of operating system, the #1 tool any advanced analyst, big data or small data, NoSQL or SQL uses is structured query language. SQL ends up coming back to us all the time because somehow it is most appropriate for doing an awful lot of stuff, even if I will use HBase and maybe I will use Hadoop and I will use Mahout. I use Mahout a little bit less nowadays than I used to. Anyway, if you look at that, you will notice that this is not the exciting world of amazing stuff at the top. Come on, there's Excel. We love to hate Excel. And it's still beating R, which is, of course, the thing we all love at the moment for advanced analytics. In fact, SQL Server, R, and Azure Machine Learning, which is part of Cortana Analytics Suite, is the trio of technologies I use. I have been using SQL Server data mining for 10 years now. You know what? It's so old, that technology, SQL Server data mining, it's so old, Microsoft even don't know that it exists in SQL Server. I'm not joking. Talk to a Microsoft person and we had data mining 10 years ago? You mean? Yeah. And I used it with clients and I still use it. I like it a lot. Part of the reason is because it's so old, I know all the bugs in it. You know, there's only about 8 bugs. There are workarounds for 5, 3 of them suck, but you can work around that in the process. I like it because it's highly visual, it's cheap, it's there. All of my customers have SQL Server, so I just say knock knock. You don't need to buy any more software. Just Rafal will make you use this software very well. Okay, it's getting old. I've been using R for about 5 years now to do the things I couldn't do in SQL Server and some cool new stuff too. And I've known of Azure ML for about 4 years because the Microsoft team invited me to be part of the early project. I wish I could tell you what was the original name of that, but I'm not allowed to. It was much better than Azure Machine Learning. Anyway, Azure Machine Learning I've been using with clients for just about over a year, even here in Switzerland, and I'm finding it very interesting for 2 reasons. One, because it's advanced, it has a lot of modern stuff which I like, but there is another reason. And the other reason is because it's just there. I don't need to ask my clients to get anything anymore. As long as they somehow manage to create a Microsoft Azure account, which if you've tried is sometimes really difficult to do, you know, all those credit card validations. No, you don't live here. I live here. No, you don't. You know, once you get that Azure account, the rest is easy. 10 years ago, when I was doing data mining with SQL Server, it was usually like at least $25,000, but typically around $50,000 that my customers had to spend on hardware alone to be able to do any advanced analytics with SQL. Now, you swipe your credit card and a few euros later, you've got all of that available. So that's one of the reasons I like Azure Machine Learning a lot. But of course, that means I have to keep my data somewhere. And in my world, as an analyst, on-prem, that means keeping it in SQL Server. The modern SQL servers come with some cool technologies like Polybase, which allow me to ignore little detail like, is the data really stored in SQL, or is it perhaps coming from a Hadoop system? They hide that complexity. They put SQL on top of NoSQL, if you think about it. If I use R, I have been using recently Microsoft's R server, previously Revolution Analytics before Microsoft acquired them. And if I need to run a Hadoop cluster on my customer's premises, I would have used Hortonworks Data Platform or Cloudera, depending on whether they were running Linux or whether they were running Windows. But even on Linux, we would have used Hortonworks recently quite a lot. And interestingly, when I say Hortonworks and Hadoop, I don't necessarily mean for processing of the data. We've been using Hadoop to keep the data as a data storage mechanism because it's so simple and so easy to dump a lot of data into it that you later process and you don't necessarily even know how to process it when you store it. You kind of come up with that idea later. This idea of using Hadoop distributed file system for data storage is very popular. I would say that many people who use Hadoop use it only for data storage, and if they do some processing on top of it, it's very minimalistic. Sometimes as simple as doing counts, word counts, and so on. And of course, we use a plethora of open source systems depending on the needs of a customer, and you've got 3 of the more popular ones mentioned over here. In the cloud, I use Azure SQL database as much as I can. Why? Because I like the line of least resistance in getting my data from on-prem to the cloud. And that line of least resistance is called what? It's called right-click. If you are a DBA, you're going to laugh, so please don't. But I like this. I go to right-click, tasks, and over here I go to deploy database to Windows Azure SQL database. And that means I can be making changes locally in my data, and with one right-click, it somehow ends up in the cloud. Why do I want it in the cloud? Well, I want it in the cloud because in the cloud I need it, of course, for Azure Machine Learning. So that's one way to do it. You can also use replication. You can use the SQL Server Stretch database, but those are advanced techniques. I generally right-click or use the migration wizard when the right-click doesn't work. Sometimes I'll keep the data in a blob, sometimes in a table, sometimes, only recently I've been trying to keep it in the Azure Data Warehouse. And of course, because I've been keeping data on-prem in Hadoop distributed file system, I am delighted that Microsoft figured out that there are many people who want to use Hadoop without the processing part. And that's exactly what Azure Data Lake is. It's a cheaper Hadoop because you only pay for storage without having to pay for processing, which I would say Microsoft slightly overcharges. It shouldn't be that expensive, but the Data Lake is okay. So if you think about those two mixing together and the way I work with the data, let me just show you how easy it ends up being in reality when I need to use it. So here I'm doing some regression analysis, and there you go. There's my Azure Machine Learning experiment, as it is called. It always starts with a reader, and that reader almost always points to an Azure SQL database which was just right-click deployed from on-prem. I like that. And if I need a transformation, Bob will write it for me. Because it's in SQL, he knows how to do it. I don't need anything else. I'm pretty happy with it that way. But it can get more complex than that. If you want to read the data from Hadoop, no problem. And there are some very cool things you can do in Azure ML that will understand that the storage of the data is Hadoop aware. For example, if I want to count millions and millions and billions of things, the best way to count things is by using Hadoop. I don't know if you know that. Hadoop's so-called Hello World application, developers understand me. Hello World is the first application you write in your life in a programming language. Does anybody know what is the Hello World application of Hadoop? Word count. It's a very simple thing that counts how many times a word exists in all of this distributed data. Well, guess what? I use Hadoop maybe 80% for doing that, for counting things, because it's so fast. So if I use Azure Machine Learning for this purpose, I can easily tell it, hey, for counting, because the data is in a Hadoop store, for example, in Azure Data Lake, treat it using MapReduce. I configure the account, I point it to a server, I give it a username and a password with which it can log in, and I don't have to write one line of MapReduce. It will do everything for me using Hadoop, using word count to efficiently count things which are stored in the data lake. I like that kind of, no-coding integration that is possible today. But of course, the reason I am showing it to you is just to make a point that in my world, all of these technologies are unfortunately and necessarily all usable today. I wish I could do everything in just SQL. I wish I could put everything in one database, learn it the best I can, and forget about the complexity of the world, but that is just not feasible. So you've seen that I have to use many different data systems. You understand that developers love different data systems for different types of application logic. Where is the future? Where is it headed? What is the direction? First of all, to the 5 people in the audience who were brave enough to raise their hand when I asked how many of you are DBAs, I have something to ask you, please, to do. Support your developers and analysts, help them with SQL. Don't tell them that their SQL sucks, because their SQL sucks. You don't need to tell them that. No developer can write SQL as good as you, so just help them. And if you are not going to help them, even if you are going to help them, but especially if you are not going to help them, prepare yourself for the near future of massive amounts of ETL that you have never seen before, for massive amounts of migration from Redis and Mongo to this SQL and that SQL and NoSQL and new SQL. Because what you have seen so far, this explosion of databases, is the phase 1. The world that's waiting ahead of us is how do we integrate all of that. And no, this is not going to happen just at web service level, at invocation level. It will happen at the data level, and it's going to cost us quite a bit of time and money and probably some crying. So will databases evolve to help us? As I already told you, NewSQL is promising. NewSQL as an idea of retrofitting traditional SQL Server, Microsoft SQL Server and Oracle and whatever else, with NoSQL technologies. In other words, to give them modeling ability that developers like, and this, we don't care so much about consistency as long as you can make it work in an enormously distributed world, request that we all have, then yes, that will be the natural choice. But it will take time. I do not see NewSQL happening any earlier than 5 years from now, and if it happens in 20, I will be quite satisfied. I think the perspective is that you have now about 4 or 5 years of this either very enjoyable time of mixing it all up, using simultaneously all of those 50 database systems that I have talked about, or you're going to have to put some control over it. But even if you put that control over it, you will not escape using a few more systems than you would comfortably like to use today. So, headache, is that the direction we are heading to? The future of data is really that data is always the same. When data is static, it's the same. No matter which DBMS you use, whether it's SQL, NoSQL, or NewSQL, it's always the same. It may have faces which are different, but the data doesn't. We need to focus not on the data, but on the change, because change is where the problem is. Change is what has many perspectives. You see, if many players change something, and then you wait while no change is taking place, all systems will eventually converge. You will always have consistency if you stop making changes. Arguably, locking does exactly that. Locking stops change from happening until we have some consistency, so this is nothing new. Now, getting it right on a global level will be very hard. We don't have solutions to that. NoSQL throws that out of the window. NoSQL says, no, we're not going to try to have global consistency of change, but we will have a local perspective of consistency. Database technology right now is evolving to solve that problem. But it is not giving you now the best choice. I'm afraid we are too early. We are at the time when the evolution is designed to give you many choices to see which ones are the ones that will work. So if you ask me to present this keynote in 5 years, I hope we will have some choices that we can recommend. But right now, I'm afraid we cannot. Today, you will have to make choices by probably making an uncomfortable compromise between lack of consistency for the gain of availability and some tolerance of network disruption, which in the distributed world is a guarantee. IoT, Internet of Things, when that car goes into a tunnel, that car will be disconnected. You have to create an app that works that way. This world, if anything, is going to get worse than better. So the future of data really is people. Future of data, the subject of my presentation, is people who understand it holistically, where you don't focus so much on the data anymore, maybe a little bit more on the change, and you think about its meaning from the perspective of what your users and your business does, perhaps no longer from the perspective of what's best for the database. And I know that's very uncomfortable for the DBAs, because to a DBA, if the database is consistent, everything is perfect, right? So unfortunately, the future of data is definitely not software today. The future of data almost definitely is you. It's people who understand for each application, for each specific purpose, how to get the data and the change into a balance, an equilibrium that your application can deliver to the user and put a smile on that user's face whilst hopefully not losing too much money to your business decision maker. I don't know how you're going to do it, but I know for sure that you will need at least 5, if not 10 of the database technologies that I have showed you here. So, only you will know how to do it. I'm sorry, if you hoped that at the end of this presentation I would tell you exactly what the solution is, then I must have disappointed you. But hopefully I have given you a way of thinking about how to make these choices. And with that thought in mind, I would like to thank you very much for listening to this presentation and wish you a lot of luck with data. Thank you.
Wonderful.